Hello, welcome to this video 2B-3. We're going to talk about how to find an inverse of a function from symbolic form. So let's go ahead and look at what it's going to take in order to be successful. In order to find an inverse, you're going to have to use this idea that an inverse is the swap of an x and a y value. And how we go ahead and find that isolate that y value is with reverse order of operations in order to solve a variable, and I like to call this SADMEP. This is an acronym that I use that helps us isolate a variable. You'll have to be able to write inverse notation, which is pretty simple, and then we'll talk about, in some cases, finding the domain of an inverse function. So let's go ahead and jump into the procedure for finding the inverse of a function given an analytical or algebraic form. The first thing that we're going to do is we're going to interchange x and y. We swap them, right? That's the whole idea about finding an inverse. And then we'll use inverse operations in order to solve for the output variable or solve for y. And again, that's that SADMEP idea. Lastly, we'll change the output variable, the y, back to inverse function notation. So that's just going to become f inverse of x. So let's go ahead and let's jump in and look at our very first example here. They say the function d is an invertible function given by d of x, which equals -3/5 x plus 4. Find d inverse of x. So again, step one here is I'm going to change out y to x. So my function currently d of x, I'm just going to replace that with a y, and I'm going to swap x and y here. So this becomes x equals -3/5 y plus 4. Now here's step two. I'm going to go ahead and I'm going to solve for y. So I'm going to use, again, what I like to write up here is I call this SADMEP. So I'm going to subtract 4 on both sides, and here it cancels, and I end up getting x minus 4 is equal to -3/5 y. Okay, I want y by itself. So it looks like I have to undo division by 5, and I have to undo multiplication by -3. So whenever you have a fraction, kind of the trick that you're going to use here is you're going to multiply by the reciprocal. I'm going to multiply by -5/3. And what you do to one side, you have to do to the other side, right? So over here it makes sense, hey, the negative cancels the negative, the 3 cancels with that 3, the denominator of 5 is canceled by the numerator of 5 here, and I have to multiply this side, which includes two terms, not just one. It's -5/3 times x, and it's -5/3 times a -4. So what we end up getting is we get y is equal to -5/3 times x minus 4. And I'm going to distribute this. So I get -5/3 x. No surprise there. But a lot of students get confused when they say, hey, a fraction times a whole number. What do I do? Well, you just multiply by the numerator. So numerator to numerator. Okay, -5 times -4. That's going to give us a plus 20. And then I'm dividing by 3. So 20/3. And there you go. There is your inverse function. Now the last step, this is, I guess, step 3, is I need to put this back in inverse notation. So the function was originally called d. I'm going to call this d inverse of x. It's -5/3 x plus 20/3. There you go. Okay, so here is a practice problem. Please go ahead, please pause the video, and I want you to find f inverse if f is an invertible function defined as f of x equals 4/7 x minus 2. Pause me, try this one. Okay, here's the solution. Step 1, you should have switched x and y, interchanged the x and the y. Everything else stays exactly the same. Then we go ahead and we solve for the y. So I added 2 to both sides, so plus 2, plus 2. These cancel. And then I went ahead and I multiplied by the reciprocal. So to undo 4/7, we multiply by 7/4 on both sides. And that got us here. And then I go ahead and I just distribute that. So 7/4 plus, once we distribute that, 7 times the 2, that's 14. We divide by 4, and there's your answer. F inverse of x equals 7/4 plus 14/4. So pretty straightforward there. Okay, next example. Let's go ahead and see what if this is a quadratic function. Now, because a quadratic function has symmetry, and it does not pass the horizontal line test. It is not invertible in its current form. And so oftentimes what you'll see with quadratic functions is a restricted domain. They say here, hey, if x is greater than or equal to 0. So, okay, that gives us just this piece. So what does that mean for us? Not much in terms of what we're going to go ahead and do, what we've been doing. But we will talk about that here in a moment when we get to part B. So let's check it out. Find g inverse of x. Okay, so if my function is defined as y is equal to 2x squared minus 5, I'm going to switch x and y. So x is now 2y squared minus 5. I have to solve for y to get the inverse function. So I'm going to add 5 to both sides. The 5's will cancel here, and we get x plus 5 is equal to 2y squared. Okay, now I want to go ahead and I want to get y by itself, so we divide both sides by 2. Watch out here. This is going to be kind of an interesting component, or an area where lots of students will make errors, is I have x plus 5 divided by 2. I have to divide each term, the numerator and the denominator. And so oftentimes what you'll see is it written like this: 1/2 x plus 5 over 2. So just be aware that when you're dividing a numerator that has multiple terms, you divide each term in the numerator. Then I'm going to go ahead and take a square root of both terms, and so we get y is equal to the square root of 1/2 x plus 5 over 2. Okay, so there is my inverse, and I'm just going to take the principal square root. I don't have the negative portion when I take a square root because my domain is restricted over here. So I want, when I switch x and y's, I want the positive output for my my function. So my range is going to be all these positive values, right? Range is all of the positive values. Okay, so what is the domain of G inverse? Okay, couple of ways that you can go ahead and figure this out, but coming from the perspective of what this inverse function, and I just realized that I should call this G inverse of x. This is a square root function, and square root functions do have domain restrictions. You're going to take the radicand. I'm going to take the portion that's on the inside of the square root, and this portion, it has to stay non-negative. It has to say greater than or equal to 0. Okay, and so I'm just going to set that piece equal to 0, and I'm going to go ahead and solve this. So I get 1/2 x is greater than or equal to negative 5 over 2. And then I'm going to go ahead and I'm going to multiply both sides by 2. And this cancels, and so I get x is greater than or equal to negative 5. That is your domain for G inverse, okay? So just saying, hey, you can't have any x values less than negative 5. The other way that you could look at this too is they give you an original domain value here, g of 0. That was like your lowest value, right? So you could evaluate your original function, 2 times 0 squared minus 5, and that gives you negative 5. So right there, that means your lowest range value is a negative 5, because this is upward opening. Okay, I kind of like this original option here, version A. Okay, and if you're ever unsure, you could, I guess, plug and chug another g value. So what's g of 1? If I plug this in, 2 times 1 squared minus 5 gives us negative 3. So you know that it's y is greater than or equal to negative 5. Okay, so that means for our inverse that the domain value is greater than or equal to negative 5. Hopefully that made sense. Okay, let's go ahead and look at a second example. Hopefully this will be much more clear. Again, if h is an invertible function for x is greater than or equal to negative 3, the function h is defined as the following. So what I'm going to go ahead and do here, and actually I believe, well, I guess they're giving us that domain restriction. Okay, whatever. We'll roll with it. Usually this would be x is greater than or equal to negative negative 4. I'm going to keep that. Let's change it to negative 4. Okay, so please make that adjustment if you're taking notes. And then let's go ahead and find our inverse. Okay, so x plus 4 to the power of 2 plus 2. I'm going to switch my x and y. So y plus 4 squared plus 2, we're going to subtract 2 on both sides. And we get x minus 2 is equal to y plus 4 squared. And then I'm going to take a square root. Okay, so I get square root of x minus 2 is equal to y plus 4. And then we'll subtract 4 on both sides. So minus 4, minus 4. Be very careful on that right-hand side. This minus 4 does not go inside of that square root. Very important. So y is equal to the square root of x minus 2 minus 4. Okay, and so there is our inverse function. H inverse of x is equal to square root of x minus 2 minus 4 on the outside. So what is our domain? Well, our domain for this inverse function is going to come from the square root symbol here. So I want whatever's underneath that square root, x minus 2, I want that to be greater than or equal to 0. And this is a really simple one to solve. We just get x is greater than or equal to 2. Okay? All right, very straightforward. Okay, here's a practice one. I want you to go ahead and please try this one. Again, for the domain, can you guys make this adjustment? Sorry about this. This should be x is greater than or equal to 1. Let's make it x is greater than or equal to 1 for that. Okay? All right, so find the inverse and then go ahead and address the domain. All right, here's the solution. B inverse is equal to square root of 1/3 x plus 1. Did you have x over 3? If you wrote it as x over 3, that's fine as well. But the first thing you have to do is divide before you undo the square root. Remember, always go back to SADMEP. Undo addition and subtraction, which we don't have here, doesn't apply. Then multiplication and division. Undo that before you go ahead and undo exponents and then redo whatever's inside of the parentheses, okay? So there's your inverse. Now the question is, what's the domain? What's the domain? Pause me here. Make sure you have this one down. Okay, hopefully you paused. You just have to take 1/3 x and set that greater than or equal to 0. Nothing really to solve here. Multiply both sides by 3. And you get 0 still. So there's your domain. X is greater than or equal to 0. Cool. Okay. The most complicated example that you can get for this on the AP Precalculus exam, it would possibly be a rational function. Find the inverse of a rational function. So the principles stay the same. Y is equal to x plus 4 over x plus 2. And I'm going to invert the function. So I get x is equal to y plus 4 over y plus 2. And then now I have to go ahead and solve this, which this looks pretty weird because I have multiple y's. So we're going to have to address that. The first thing that we're going to do is I'm going to get rid of this denominator, which is a y plus 2. I'm going to multiply this side by y plus 2. So this cancels. And what I get is I get x times y plus 2, which is equal to y plus 4. Now I want to get all of my y's together, and there's no way to go ahead and move this y plus 2 back over unless I divide, and then I'm back in the same spot. So what I'm going to do after I do this is I am going to distribute, and what I get is I get xy plus 2x. And you're like, Schwarberg, this does not look any better. Well, what I've done now is I've made individual terms that I can now add and subtract. And so what I'm going to go ahead and do is I'm going to take this xy and I'm going to move it back over to the other side, minus xy. This cancels. And then this, well, I don't know. Let's do this. So we now have, what, 2x is equal to y plus 4 minus xy. And I'm going to take this 4 and get rid of it. Move it over here. And so here's what I'm trying to do, is I'm trying to isolate my y's. And so hopefully what you see is, hey, I have all y's on this side, okay? So to get y by itself, I'm going to use this idea of a greatest common factor. I'm going to factor out a y, and that leaves behind 1 minus x, 2x minus 4. Now I'm going to isolate my y. I just have one y, I want it by itself, so how do you undo multiplication? You divide. So I'm going to divide by 1 minus x. Okay, and so here you go. Here's your inverse. This is called r. R inverse is going to be equal to 2x minus 4 over 1 minus x. There's your answer. Now, if you did this another way and you possibly move the y terms to the left-hand side, another equivalent answer would be negative 2x plus 4 divided by x minus 1. You can go ahead and just change the signs on everything, each term. I hope you noticed the sign changed. Those are equivalent. It's the same idea as if I factored out a negative out of the numerator and factored out a negative out of the denominator, and those would cancel. So both of these representations would be correct. Okay, please go ahead. I want you to try this one. Try B, and I'll show you the answers here in a second. Okay, let's go ahead and look at this example. Hopefully you called B y, and then you interchanged x and y, and you have to isolate y. So you're going to multiply both sides by y plus 8. Cancels on the right hand side. Now I have it multiplying with the x on the left hand side. And then you actually don't have to do this, but to stay consistent, I did distribute this x to both terms. You get x plus y plus 8 times x equals 5. And then I want to isolate my y, so I subtracted the 8x. And I have xy is equal to 5 minus 8x. I divided by x, and you get your inverse. This is a correct representation of this inverse, but we can simplify and reduce, so you could see this as an option if it were a multiple choice question, or potentially the middle one here is unlikely. If I divide both terms, right, by x, the numerator has to have both terms divided by the denominator, and then I reduced on the x's for second term. That would just be a minus 8. So I like this form the best. B inverse is equal to 5 over x minus 8. How'd you do? Okay, hopefully in this lesson you went ahead and you could use reverse order of operations to solve for a variable, and specifically the inverse. Hopefully you were able to write inverse notation, and on those quadratics we could find the domain of the inverse of the square roots. Go ahead, give this video a thumbs up. I'll catch you in the next video. See you later.